Okay. Welcome, everyone. Thank you for attending today's talk. And today I will be talking about why forks fail often, or changing risks with unchanged code. First, let me do the world's fastest intro. I'm engineer, and I do security at yAudit Y Academy. Today we also have some Y Academy and yAudit stickers on the white table in the back, so you can grab them after the talk. If you want to copy the slides, they are online. You can go to engineer.com and find a link. There's also a QR code, but if you're using the QR code, I know you're not really in security because I could have just put a Rickroll link in the QR code. So anyway, no, the QR code works today. Next time, though. Security. Securing code is hard. And making sure that secure code is actually secure is also difficult, ironically. So there are two ways in which secure code can actually become insecure. And the first one is when you change secure code. Anytime you change code, the assumption in this day and age is that you get an audit and make sure that the changes are not changing the security stance of the code. But the second case is much more interesting, and that is when something outside of the secure code changes. And this one is usually ignored entirely, but this is what we are talking about today. Context makes security hard, and we know in this space security just on its own is very hard. The ecosystem moves very fast, and any change can cause issues. In fact, this is not just true in this space, it's also true in the real world. If you are changing something in your environment, this can sometimes cause issues. Security scope is not just the smart contracts that the developers wrote. When you're doing a security audit, it's actually the developers usually specifying the scope. And when the code is deployed on chain, the code is usually not working in isolation. It's connected to things. It's connected to an ERC20 token, and this is a separate contract. It's connected to another DeFi protocol. That's also outside the contract. But when you do the audit, those are considered out of scope. There's a butterfly effect. You're never working completely in isolation. When code is on chain, it's interacting with other components. And this butterfly effect can create a scenario where a change somewhere on chain can impact something somewhere else entirely on chain. So the question is, are we building DeFi money Legos, or are we working on DeFi quicksand, where any small change can create huge impacts elsewhere on chain? First, let's talk about audits. The general way things work today, for those who are not familiar with security audits, is that when you have code and you want to make sure it's secure, you call up your auditor buddies and say, hey, I need you to come over here. And the auditor prances over on their unicorn, they sprinkle security dust on your code, and then they give a giant stamp of approval saying this code is secure. And it works, right? I mean, if you go to crypto Twitter, you're going to see people like this saying, oh, audits, I'm the best auditor in the world, and my audits are bulletproof. I'm just amazing. But unfortunately, this is just what you find on crypto Twitter, and we all know don't believe crypto Twitter, because audits are not bulletproof. Surprise, surprise. First of all, as mentioned, the audit scope is actually chosen by the developers because they're trying to get lower audit prices, and they don't want you to review literally everything on chain. So they will say, focus on the code that I wrote and ignore the other stuff, because what I wrote is important and no one else is important in this world. So this stuff that's outside of the scope can often cause problems. If you're competing in a code auditing contest and you find an issue out of scope, sure, it might lose users' value, but you're going to get knocked out as an out of scope issue, which no one cares about, no one will pay you for, so it's pretty useless. Even though users might actually care. So there's this misperception of if everything in the scope is bug-free, then users are safe. But this is a bad assumption, and we need to think outside of the scope. Think outside the box and outside the scope. So I want a quick audience interaction moment. I want you, after this very short introduction, if you think that forking secure code is always safe and secure, raise your hand. Okay, Just for the recording, I'm going to count how many raised hands we have. We have 1, 2, 3, 4, 5, 0. We have 0 raised hands because, yeah, no one thinks this. And I have to say, either all of you in this room are security geniuses or you're all from Montenegro. 0 raised hands. So, but why is this? Because if you fork secure code, it's secure code, right? I mean, there's no difference. So what is going on here? I mean, there's something more at work if you can fork secure code and then the new code is insecure. And this is just a sample of hacked forks taken from the link at the bottom. And actually, the screenshot is only hacked Compound v2 forks. Now, I'm not trying to pick on Compound v2. It just so happens it's a very popular protocol to fork, and many people do it wrong. But it's an example of forking code doesn't mean you will be as secure as the original protocol. There's Aave forks as well in this repository, and I can guarantee you basically any commonly forked protocol will have a list like this, sadly. But why? Why? This is what we're wondering. Why can you fork secure code and have insecure code? So the main message I have today is that context is everything. If that's the only thing you take away from today, just remember context is everything. Your code is never working in isolation. It's operating on chain. When you do an audit, normally the code is not deployed yet, because if you deploy code without an audit, that's just asking to be wrecked, so no one does it. But you need context at the end of the day. So we're going to talk about a few of the ways in which forked code can become insecure, even though the code itself has not changed. So these are bugs outside of the contract code that can cause real issues for real users. So just to highlight the quick list in a quick summary before we dive into each one in detail, the first one is governance design changes, and the second one is governance decision changes, not to be confused. Thirdly, blockchain parameter changes, actual changes to the blockchain itself. Then we have EVM change differences and changes, and other protocol changes. But let's dive in, starting with the first one. Governance design changes. So when you have a protocol, normally it is not completely immutable. There are a few protocols that are completely immutable. It's deployed on chain and cannot be changed further. That's amazing from the perspective of, let's say, safety of governance manipulation, but it's not a common approach at this time. So normally there's some governance role, admin, owner, multi-sig, something like this. But doing this properly is hard. First of all, an EOA is not a multi-sig. This is pretty obvious, but you'd be surprised how some people need to be reminded. Secondly, multi-sigs are not all the same. A 1 of 1 multi-sig is not the same as, say, a 5 of 8 multi-sig. 8 multi-sig addresses, if they're all owned by one person or one EOA, that's not really that secure. It's almost the same as the first case of just an EOA. And finally, if you are forking a protocol and you decide, let's put in some proxies, proxies can cause issues. I won't go into this now, but there is separate research on this, which I can point you to if you'd like. And if you don't believe me, if you think, oh, governance, no one cares about this stuff, it's not a big issue, I'd like to point your attention to item number 4 on this top 10 list of common hack vectors, which is stolen private keys. And this is very clearly a governance design issue, where if you are not designing your governance properly and you become a target and someone steals the private keys for the governance, then your protocol is basically sunk. You're wrecked. It's gone. Bye-bye users and TVL. So I want to give a shout out to Ifelix, the guy who's created the Block Threat newsletter. Highly recommend you sign up for it. He does some great research analysis and keeps up with everything in the space somehow. Okay, if you've ever used the internet and made an account, this image may look familiar. When you create a password for an account on a website, you'll often see a little indicator of how secure your password is. And we don't have anything for multi-sig design changes or design decisions. So what would be great, this is like open-ended research, and if you can take this, if there could be some indicator of putting in a multi-sig address and just seeing how secure it is. Is it a one-of-one multi-sig? Do the multi-sig owners change often? Is the owner of the multi-sig, is there a proxy in there where the owner of the proxy is an EOA? There's many ways in which a multi-sig can be visible but insecure. So just saying there's a multi-sig is a very bad answer. There's a lot more detail that can go into this. Okay, time for number 2. Governance decision changes. And I really love this graphic. Yeah. Anyway. So governance decision changes happen all the time. So if you have a protocol that is a lending protocol, such as Aave or Compound or any similar protocols, there are only specific tokens that can be borrowed or lent to the protocol. And when a new token is to be added to the protocol, this is a governance decision. They need to go through the governance process and approve that a new token is being added. But what can go wrong? Well, that's why we're here, because there have been many hacks of forks due to this exact issue. Firstly, if you support a token with reentrancy, this is just asking for problems in a Compound v2 fork. There are several instances of this. If you support a token with insecure price data, the price of the token will get manipulated, and once again, a lot of funds will be gone. Now, the superset of these issues might be considered to be supporting weird ERC20 tokens. These are tokens with unusual features or unexpected code in the token. And I use the term weird for a reason. That's because there's actually a great collection of these tokens at the GitHub repository listed here. So yeah, this is an example of governance deciding something that effectively impacts user value and user security. Second example, the same types of protocols, lending protocols, have interest rate models. The goal of the interest rate model is to give the lenders good interest rates. You know, everyone likes yield. Everyone likes 5-digit yield, even more. But you need to offer the yield in a way that's not compromising on security. And bad debt is one of the factors that limits how much yield you want to offer to users, and also the cost for borrowing. So basically there's a compromise or a decision, an optimization puzzle that needs to happen between reducing the risk of bad debt, which means keeping the interest rates high for borrowing, but then also choosing an interest rate that encourages borrowing so that users can get yield. So this is like an optimization puzzle that highly depends on market conditions. And because it depends on market conditions, the market's never stable. I mean, we're in crypto, it's like super volatile. I mean, you're probably checking prices every 5 minutes is my guess. This needs to change in lending protocols. And if you're changing it on one chain, the interest rate on a different chain for the same token may need to be different. So you can't just copy paste the USDC interest rate model to every single chain because market conditions may vary, liquidity varies, so this is really a difficult puzzle. Here's a visualization of what I'm talking about. If you have dealt with any of these borrow lending protocols, you may know that a lot of them use a two-piece, piecewise defined curve with 2 pieces, and these colorful lines are merely showing different design decisions. So for the exact same asset, DAI, Compound and Aave have chosen different interest rate models, and then this protocol X, which shall be unnamed, has a different design decision. So none of these is particularly right or wrong. There is no right or wrong answer, but there's different risk decisions involved in this. And if you're making a decision that's more risky, at minimum, I would think you should notify users of the explanation behind this, or you just assume users are educated, which is a very, very bad design decision in this space, as the meme coin holders will tell you. So yeah, this is difficult. I really don't know of much research on this topic of good governance decision making. There is this one article written by Alberto Cañada-Cuesto, and so I would recommend if you're involved in any governance decision making to take a look. Okay, we've looked at governance. Now let's look at the actual blockchain. So you might think, well, I deployed my contract onto the blockchain. It runs. You don't have to worry about it, right? It's running. You can sit back, relax, collect the tokens or whatever you're doing. But that's not necessarily the case, because even the blockchain itself is changing. And perhaps the biggest example of this is Ethereum's switch from proof of work to proof of stake. If you deployed your contract with certain assumptions that proof of work operates in a certain way, then the blockchain basically broke your assumptions. It switched to proof of stake. And the best example of this is Uniswap v3 TWAP oracles. There were certain assumptions made for how difficult these are to manipulate using proof of work. And because these were deployed with the proof of work Ethereum processes initially, the proof of stake switch mean that these security assumptions changed. And there's a great article here, but I'll just demonstrate one key takeaway. With proof of stake, it's much more possible for someone to build many blocks in a row and know in advance. So they can basically do some sort of MEV or price manipulation. And I didn't even have to look hard. This was literally just on Etherscan when I opened it up the day I made these slides, that this one builder built 5 blocks in a row. This was just like the first page. So this is a demonstration that proof of work, it may have been different assumptions, more difficult to do this, and proof of stake changed that. So keep in mind the blockchain itself is changing, which is like kind of crazy to think about, but even after you deploy code, you need to keep track of what's changing. Another example, how many of you have heard of an EIP? Okay, all hands, hopefully you're all awake. Good. Maybe you're not all from Montenegro. So EIPs are basically changing Ethereum, and when these changes happen, this is changing certain things on chain. I mean, that's just how it works, and these just keep happening. It's not like Ethereum is stationary. So this is one example when new opcodes were added. These opcodes could introduce an edge case of a new reentrancy risk. Now, this wasn't like a common problem. Most likely you're not affected, but it's a new consideration to take into account that was not a problem before. This is just an example of some of the latest EIPs that were introduced to Ethereum, and all of these are now on-chain. EVM chain differences. EVM compatible. What does that even mean? I have no idea anymore. Yeah, EVM compatible chains are not all the same as Ethereum mainnet. There's a lot of differences on these chains. I think we'll actually have a speaker talking later today about more of that. But this is just one website that shows the differences between different EVM compatible chains. They're not all equal. And as a demonstration, I think developers were thinking like, oh, I can deploy on mainnet, but I can also deploy the same code on these other chains and get some incentives. So, why not? But just copy pasting the code is not always a good practice. And we'll get into why that is. Here's an example. There was an EIP, 1559, and it was deployed on mainnet Ethereum in August of 2021. Now, different L2 chains didn't get it until 1 to 2 years later. And I wouldn't be surprised if there are other examples of this where there's an EIP put onto mainnet and then the L2s don't adopt it until much, much later. So I'm not saying that this was actually a possible hack vector for anyone, but it deals with the assumptions built into the code. If you're using assumptions and then you deploy in a place where those assumptions aren't true, this can cause problems. Let's look closer. Same EIP. Now we're looking at optimism. And the optimism docs actually show that the implementation on optimism is different than the implementation on Ethereum. So it goes even deeper. You can't just say, oh, okay, I'm going to deploy on this chain. The EIP is there. Life is good. Because the EIP might not be the same. Even though the number is the same, the chain is different. They change things under the hood. And if you're not looking, you might get some issues. Here's just a few other EIPs that might have some impact. Adding or removing opcodes can also be an issue. I think push 0, the opcode addition in particular, there was a lot of talk that that rollout between different L2s was a little bit rough, so to speak. For those of you who like colors, I have some colors here. Let's look at gas. On the left, we have a chart from Etherscan showing the average gas limit on Ethereum mainnet. And you can see it sort of changes every now and then, sort of like a step function. And now it's about 30 million, roughly. Over on the right, we have BNB chain, everyone's favorite chain, I'm sure. You're using it every day. And the gas limit is about 140 million. So again, this might not be something that your code is impacted by, but this is a different chain. It may be EVM compatible, but I have no idea what that means because different things under the hood are different. But you know, everyone likes to choose their favorite BNB chain. Let's look at something else. Here we have Optimism mainnet, and you can see the graph looks very different. There's just 2 steps. And while the average gas limit now is exactly 30 million, that's different than the roughly 30 million of Ethereum mainnet. So even in Optimism, there's some difference. And then on the right, we have Linea. I don't know how they chose 61 million, but it's just been stable, maybe because it's a newer chain. But again, we have differences. All these chains are using something different. There's basically no consistency here. I didn't even put Arbitrum because I think for Arbitrum, the value is just huge. I think it's like billions, trillions. So yeah, it's just off the charts compared to these values. Yeah, this is what happens. There's 14 chains, they're all EVM compatible, and then someone says, but my chain is more compatible. And then the EIPs come along and we get back to the start. So this is what's happening now. It's a tough life. Okay, so other protocol changes. What do I mean by this? Let's say you are a big DeFi money Legos maxi, and you build on top of another protocol because that's how DeFi money Legos work. Well, we've seen recently that there's some scenarios where the Legos turn into quicksand. I don't know if any of you were following this drama with Morpho, but Morpho is built on top of Aave and Compound. And there was this quote in a recent Aave proposal that Morpho optimizers are a leech on top of the Aave protocol. This doesn't sound particularly good, and it doesn't sound like someone who's a DeFi money Legos maxi speaking. But what ended up happening is there was actually a new rewards program added to Aave that was attempting to break the Morpho model, reducing the rewards that Morpho got. So this is just an example of you might build your protocol on top of something else, but if you're building on top of something that can be modified with governance decisions, then you're basically at the mercy of the governance of the other protocol. So immutability is nice to have in some cases, not nice to have in others, and it's just something you need to factor in. Because this is almost like a butterfly effect. You change one thing in one protocol, other protocols get affected. Let's talk about flash loans, everyone's favorite. This only took like 3 minutes to find all these headlines about flash loan hacks. I didn't even try. I just took the top results. There's a lot more. But flash loans were not always on chain. They were introduced at some point. It was considered an innovation. You can just borrow instantly, basically zero cost, just for a block or less than a block. How amazing is that? Well, some people found it really amazing, and it caused a lot of issues because some protocols were built with the assumption that, you know, very few people have $100 million. I mean, what's the risk that this mega millionaire is going to hack my protocol? But then when you make it very accessible to borrow 100 million, that changes some of the assumptions and makes this accessible to literally anyone. So flash loans, adding these on chain, you know, an innovation really impacted the entire ecosystem. Once again, this is like the butterfly effect. You change one thing, you add a feature in one protocol, and then others can leverage that feature in unexpected ways. So I'm not saying we've seen anything as impactful as this recently, but it's not out of the realm of possibility. There could be something new that comes along. Finally, we have discovery of new hack types. So if one protocol gets hacked in a new way, other protocols with similar designs might be impacted. It's always something you need to keep track of, new knowledge sharing in the space. Just an example, if one fork gets hacked and there are other forks like it, then you really need to be worried, because if you're all using the same code, why didn't you get hacked yet? There's either a difference in the code or you're going to be next. So those are always worrying scenarios. Okay, I just ranted about a bunch of risks. What do? Do we say that these can be prevented before the protocol is deployed? So like you do all the work up front and you forget? No. Okay, that's hard. Do we give up? No. So what's the answer? The answer is security extends beyond the audit, and context is everything. You can't consider the code in isolation. So I'm not going to run through all of these due to time, but here are some suggestions on what smart contract developers can do. And then these ones are for before deployment, and these ones are after deployment. So even after deployment, there are some things you want to do. Keep track of EIPs, check for changes in the dependencies you have, and look for new hack vectors. So remember, context is everything. Bugs might be expected in the scope, but bugs can happen outside the scope. So keep your mind open. Don't think inside the box. So quick summary, here's those 5 points again. I won't go through it. Remember, context is everything. Thank you. One question. See who the lucky winner of the one question is. We have one in the back. I'll repeat the question. How to track the changes? Which changes? Like dependency changes or chain changes? All of them? All of them. Live on crypto Twitter. I think tracking EIPs is relatively easy because EIPs don't get implemented on a daily basis. So this, you might be able to just keep watch of new EIPs coming, new hard forks. As for dependency changes, setting up monitoring is one option. There are many ways to do this. I think Tenderly has various alerts you can use. There's, I guess, for changes in knowledge in the space, if there are hacks, you can watch crypto Twitter, you can check rect.news. These might notify you of new hack vectors, which you might want to be aware of. I hope that answers the question of how to keep track of these changes.
All right. Yes. You mentioned the T-store and the T-load.
Yes.
It can introduce issues. The fact that these two opcodes are added to the VM. Is there an example of a protocol that was attacked because of that?
Not yet, but this link is a great article written by Chain Security. Shout out to Chain Security, explaining a possible risk here with reentrancy. And I'll go back to the QR code real quick, just so if anyone wants the slides. Of course, you should not use a QR code. You should write it manually, but there you have it. Thank you.